Hi again, welcome to the next video in the calculus series. In this video we review the concept and the technique of developing integrals which require us first to differentiate a function and second to integrate the result of that differentiation to find the answer we require. It is a powerful technique for more complex integration. It can be used with any type of function in addition to basic functions, so with exponential, logarithmic and trigonometric functions. When integrating functions, we often consider two techniques which are closely related but which differ in their approach and strategy. The techniques are the two-stage one of differentiating and then hence finding, and the reverse chain rule. The first of these techniques is based on the concept that on some occasions, not too many, an integral can be made more direct if we differentiate a related function first. Of course, we have to figure out which the relation is, and sometimes that's given to us. Using that derivative, the integral becomes manageable, sometimes being just a simple term, but at other times separating into maybe two or three relatively easy terms. Almost always, the question is posed in two parts, so it's easy to see what we have to do. The first part says differentiate the following function. The second part says integrate another but related function. With such a structure, the nature of the question is really obvious. There are, however, two types that we can be asked. First, questions producing only one term to integrate, and the second type is where questions produce two terms to integrate. We start with a nice straightforward one where we have only one term to integrate. A question might be differentiate x cubed minus 10 all to the fifth. The second part of the question is going to be hence find the integral of 15x squared x cubed minus 10 to the fourth dx. Here in the second component, after the integral sign, we have a function which is related to that given in part 1. So we'll do part 1, which is a nice easy chain rule. The derivative is bring the 5 down the front, rewrite the bracketed term, take 1 off the index to make it a 4, multiply it by the derivative of what's inside the brackets, 3x squared, tidy it up, it becomes 15x squared, bracket, x cubed minus 10 all to the fourth. Now in part 2 we follow the following steps. First of all, we're going to write down what we've done, so the derivative of dx and so forth, just copy it down. Second one is to add integral signs and a dx to every term, so we've done that in red here. And the third one is to integrate all terms we can. Well, the integral of the derivative in the left-hand term is nice and straightforward because they cancel each other out, always. So we're simply left with x cubed minus 10 all to the fifth. And we can't do anything with the right-hand side because that's going to be our question. So we just rearrange by exchanging the two sides, and with nothing to tidy up, but we add a plus c, so that's the answer. Nice and straightforward. Our second example is where we have one term again, but when we integrate there are adjustments to be made. The example is differentiate 2 minus root x all cubed, and then we have to integrate in the second step that thing that you can see there. Well, let's do the first step first. We're going to differentiate that by writing d dx to indicate that we're going to differentiate it. We never write y here, it's always d dx of the function. So we do our chain rule by bringing the index down the front, we rewrite the brackets, we take 1 off the index to make it a 2, and then we have the derivative of what's inside the brackets, so the minus root x goes to minus x to the half. Differentiating that we have minus a half times 1 over root x, which I've written together. So now to find the integral we require in the second step, we're going to write down what we've done, just with the d dx terms and so forth. We're then going to add the integral signs to both sides and dx to each term, and so we've now got a structure that we can use. The integral of the derivative of the left-hand term is simply going to be the term itself, so I just note that. And I can see that the right-hand side is going to be the question. So I'm going to interchange my terms and just simply write minus 3 and then 2 minus root x squared over 2 root x dx, and then the other side is 2 minus root x all cubed. I know that I have to get rid of, when I'm rearranging and tidying up, I need to get rid of that minus 3 over 2 on the left-hand side. So I simply multiply both sides by minus 2 over 3. So that gives me what I want to get the left-hand side in term, and the right-hand side then becomes the answer. So I'd simply rewrite it and add C. In our third and last example, we're going to have two terms to integrate in our second step. So the example is going to be first to differentiate x root 2x minus 1, and the second step is going to be to integrate that function you can see there. So using the product rule for part 1, we're simply going to do our normal thing. So we're going to get root 2x minus 1 plus x over root 2x minus 1. So there's our two terms that we're going to have as characteristic of this kind of question. In our first step in part 2, we're going to add our integral signs and dx to every term. So we're going to have 3 integral signs in this particular section. We're then going to integrate every term that we can. On the left-hand side, the integral of the derivative just cancels out, so that's fine. In the first term on the right-hand side, we're going to rewrite that as 2x minus 1 to the half, and then the second term we're going to leave because that's the term that we have to answer to. So we'll rewrite things now by leaving our question on the left-hand side and taking our integral sign of the one we can still do across to the other side. So now we've got two terms on the right hand side separated by a negative. We can't do anything with the left hand side, that's our question. Our right hand side has got already one term in fine form, and then we're going to integrate the 2x minus 1 to the half by making it 2x minus 1 to the 3 over 2 divided by 3 over 2, and then also divided by the derivative of what inside the brackets, which is a 2. So the 2x minus 1 to the 3 over 2 can be split up into 2x minus 1 times the square root of 2x minus 1, which then gives us a common term in both the first and the second terms. So we're going to take out the common factor of 2x root 2x minus 1, and then we're left with 3x minus 2x, which is x, minus 1 over 3. So that gives us our answer, plus C. The three examples we've worked through are the three main formats for the questions related to differentiating, hence find integration. A short summary of the steps required was given as we worked through each example, but a more detailed summary is provided on the website through the Calculus Integration main page, and then look under Differentiate, hence find. Review the concept and the steps there. Print it out if you consider having a hard copy as useful. So that is the approach to integration in the context of differentiating a function as a first step. The approach is allied to that called the reverse chain rule. I have reproduced the steps we have followed here on the website together with a comparison with the reverse chain rule. Practice these steps until you find this approach is really straightforward. Thanks for watching this video. Go and do some integrations and test yourself one on my website at drjoesmaths.com. Good luck. See you in another calculus video.